All right, enough talking about R. Let's actually do some R, shall we? So I'm going to start by clicking on my projects. Just happens to be that my instructions are embedded within my research methods R project. And once I do that, it will open up an R Studio instance like this. And then what I can do, if I were you, what I would do is I would go to File, New File, R Script, or hit Shift Command N. But for me, I've already actually saved a file. And so I'm going to go to that and click on R Basics. Now, let's say, and these are basically my notes of the things that I want to cover. So let's say that you have a list of items that you want to buy for school, and you want to see if you can afford a new iPad. And so what you can do is you can use R as kind of sort of a complex calculator to do that. So let's just go through this. And as we go through, I'm going to teach you a couple of things about R. So what I might want to do is I might want to start by saying money is equal to 1600. And so basically, that is telling R to create what we call an object that stores the value of 1600. And so now if I were to type in money and then send that line to the editor, and again, I did that by hitting Command Enter. If you're on a PC, I believe Control Enter will do it. Just like my first mate, it will say money, and then it will tell me the result. So 1600. So I have created in R's memory an object called money, and its value is 1600. And let's say that there is an iPad, a refurbished iPad that I wanted to buy for $220. And so I will create a new object. And again, if I highlighted iPad and then hit Command Enter, it will report the results. So far it looks like R has stored in its memory an object called money that is equal to 1600 and an object called iPad that is equal to 220. Now let's say I want to list the items that I know I have to buy. So maybe I have to buy a laptop, I have to buy textbooks, and I have to buy clothes. And these are all the things that I have to buy. And so instead of doing a new line like I've done here, you could separate items by semicolon if you wanted. And so if I ran that, notice down my editor, it said I ran all that and everything should be good. If I were to highlight books, for example, and run that again, it would just report what I already told it. And so now let's see what happens when we add up all these items, laptop plus books plus clothes. Like I said, you can use this as a calculator and then see how much money I have remaining. So I'm going to go money minus, and then just add those three together. And so if I did that, I can then report to myself how much is remaining. And so I have $197 remaining. So I told R store in an object called remaining however much money I have remaining, which is a function of that calculation right there. And so here's a couple things we could do. We could see if remaining is more than an iPad. So I'm going to create a new object. By the way, I'm kind of hitting you over the head with this idea of objects. I'm creating lots and lots of different objects because that's what you're doing in R all day, is you're creating lots and lots of objects. So you might create an object called Can I Afford? And so, and we are going to make that equal to remaining greater than iPad. So basically what this is doing is this is asking R a question. It is saying, is remaining greater than iPad? And if I ran that, and then again I can highlight that, and then run that, it will return false. And so what I have just done is I have created a special object called a logical object. And a logical object can either be all caps true or all caps false. And that has some special properties that we'll go into later. But so far I've created just an object that stores numbers, or a couple of objects that stores numbers. Now I have an object that stores a logical value, either true or false. And in this case, it was false. So darn, I cannot afford an iPad. And so then I might ask, how short am I? And so I can, again, create a new object, which is the difference between how much is remaining and the cost of the iPad. And remember, the iPad I stored up here. So R is going to remember how much an iPad cost, and it's going to remember how much is remaining. And then if I run those 2 lines of code, it says negative $23, or I am $23 short. Now, all that I just showed you so far is kind of, and by the way, what I just did is I just saved. I would save religiously, just because you never know when things are going to crash. Anyway, so what I just did was a very inefficient way of doing things by creating separate objects for each individual item we need to buy. Instead, it might be better to put those into what we call a vector. And so we can do that by using C. C is short for concatenate, which, as I wrote here, is fancy speak for putting together a bunch of objects. And we're going to put them together in what we call a numeric vector. And so I'm going to create a new object called expenses. And expenses is equal to putting together the object that I created earlier called laptop, the object that I created called books, and the object that I created called clothes. And now if I run that and then ask R to give me a look at that, notice that it didn't do anything. It didn't like sum those numbers up or anything like that. It created a vector, is what we call it, of 3 different things. And this is a special type of vector. This is called a numeric vector, which means that it is a bunch of objects stored together, and all of them are a number. So that's what a numeric vector is. And so now we have a new problem, though. We used to have like the names attached to them, and now we just have 3 numbers. We don't know what they are. So now, instead of doing that, we might build what's called a data frame. So if you've ever used Microsoft Excel, you can think of a data frame like an Excel spreadsheet. So in the columns, you have the variable names, and in the rows, you have each of the different instances of that. And so we're going to create that. Now, normally, you would actually maybe use Excel or use Qualtrics and have some other way of creating your data frames and then just import them. But I'm going to show you how to create a data frame just because it'll help you learn certain things. So we're going to create a data frame that stores all that together. But first, we need to create a new vector, but this is not going to be a numeric vector. This is going to be what we call a character vector. And a character vector stores a bunch of character objects together. So if I ran that, and then again, if I highlight items and then hit enter, it's going to report what I stored in it. Now, I know that I misspelled laptop. I did that intentionally, and you'll see why in a minute. So we've got 3 names, basically: laptop, books, and clothes. And notice when I did this that I put this in quotes. Here, I don't have quotes. What I'm telling R here is store in that expenses vector the object called laptop, the object called books, and the object called clothes. And again, when we run that, it doesn't store the name laptop, the name books, and the name clothes. It stores whatever that object contained, which was 854, 321, 228. Here, on the other hand, I'm putting it in quotes. I know a lot of students in the past get confused about when there's quotes and when there's not quotes. You put quotes around something when you want to give it a name. There are no quotes when you're referring to an object that you have created in R. So in this instance, I am creating a new object called items, and in that is stored these 3 names: laptop, books, and clothes. And again, like I said, we need quotes for the names. Any ideas why? Because otherwise it will assume you're talking about the object called books instead of the name, quote, books. All right, so now we've got an object called expenses, which lists how much they're worth, and then we've got an object that lists the items in quotes, and then now we'll create what's called a data frame. And again, a data frame is like an Excel spreadsheet. So we're gonna do that by saying expenses equals data.frame, and in parentheses we're gonna say, we're just gonna name. So a data frame is basically a way to store objects within objects. So look here, I'm creating something called an object called expenses, but then within that I have another object called item and another object called cost. And so I'm saying, all right, in this data frame, I want an item that stores the information contained in items. And again, items is just a string of names. And then I'm going to create another object called cost that has the expenses. And so once I run that, what do we get? We now get an Excel spreadsheet looking thing that has two column labels, item and cost. And that came from there and there. And then containing that is the names that we provided it and then the values. And then let's say at this point we say, oops, I misspelled the name of laptop. Let's go ahead and copy and paste that code. Now, if I were you doing this along with me, I would actually do that. Hit copy. Actually, I'll go ahead and do it again. And then paste, except I'm going to change that from labtop to laptop. And then I would take this line 36 for me, copy that, and then paste it over here. And then if I run line 41, and then line 42, and then now, do you anticipate a problem? Well, let's look at it. Okay, we do have a problem. Now we have item in there twice. Why do we have it in there twice? Well, when we originally created this data frame called expenses, we told it to fill it with this information and this information. But what we did was we had expenses here, and then when we created this new data frame, we used the same name. And so now, earlier expenses was just 3 numbers. Now expenses has become a data frame. And then when we now say, all right, let's create a new data frame called expenses, which is equal to items, which is that, and then expenses, at this point, expenses is actually a data frame. So we're asking it to combine laptop, books, and clothes with an existing data frame. And that's why we end up getting mostly duplicate columns, except one of the columns is corrected. So what is the take-home message here? The take-home message is that you should treat R like a final paper. If you were writing a paper for a publication, for example, you would never leave a typo in there. You would delete the typo. Or maybe you had a sentence that you wrote 2 ways and then decided, I like this way of writing the sentence. You wouldn't leave the second sentence in there. You would delete it. And the idea is that anybody who's reading this document, it is quote-unquote self-contained, that all the information they need is within that one document. There's no redundant information, there's no extraneous information. You have exactly what you need in that script, or in that paper. And likewise, it's the same for R, that you treat it as if it were a final paper, that you want all the information in here to be self-contained. If you make mistakes, you delete that instead of stringing it down towards the bottom. So what I'm going to do is before I do that, let me show you one thing. You could always look at the object in R's memory by typing ls open close parentheses. And this tells us that we have created objects called books, can I afford, clothes, difference, expenses, iPad, etc. And so what I'm going to do is, I know that the expenses thing has just gotten messed up. And if I were to run that code again, it would create a 3rd column, and I don't want to do that. So what I want to do is I want to restart R and clear its memory. And so to do that, okay, you're going to go to session, and then you're going to click on new session. That usually doesn't happen. Hopefully that doesn't happen with you. Okay, back to R. Okay, so now we can double check and make sure that we cleared R's memory. And so I'm on this line right here, and I'm going to read that in. And when it says character 0, that means I ain't got nothing. So, round of applause to you. You have cleared R's memory. So, what is the take-home message here? Like I say in the notes here. Whoa! Like I say in the notes here, treat your R scripts like a final paper. We only want to keep what is necessary, and everything should be self-contained so that next time you run it, you can run it from the beginning and everything works out well. So let me just do a quick review of what we're doing so far before we move on. First, know what an object is. Second, know what a character vector is, a numeric vector, and also data frames. And again, data frames are like Excel spreadsheets that have rows and columns. And also understand the final paper idea and why. You're not going to be able to understand exactly why quite yet. You'll see that more importantly later. So now what I'm going to do is to make my paper self-contained, I'm going to go back and I'm going to save a new version. File, save as, and then I'm going to call this rbasic/for-reals. So now what I'm going to do is I'm going to go back and correct the problems that I made and make it so that it is a self-contained document, so I'm not creating objects that are confused with other objects. So let's see, what can I get rid of? So I'm going to get rid of, another thing I like to do is just get rid of the things where I am just reporting things to memory. Actually, I'm going to start with, I'm just going to get rid of that stuff and start with expenses, and I'm going to change that to laptop, and then maybe what I'll do is I will change this from expenses. I don't want to use the same name twice just in case I get into the same problem I did before. So maybe I'll call this costs. And then we've got costs and items, and then now expenses. We got item equals cost and cost equals costs. And then I'll get rid of that as well. And then now, when I run it from the beginning, we get exactly what we wanted. Wahoo! And I'm gonna go ahead and get rid of that. So again, we're just trying to make this concise and easily readable. So now we have something that is much easier to deal with. So, there's a couple things we could do. We can sum up the expenses, and what? Oops! Why is it having a problem here? Well, it's because it can't sum up a character vector. So, what is the sum of laptop, books, and clothes? You can't sum up names. And so, instead what we can do is we can say sum expenses $cost. And so what we are doing here, you remember how we return the item just by highlighting the name and then hitting Command Enter, Control Enter. Well, if you want to index something within a data frame, you've got to use what's called, well, you got to use the $sign. So that tells R to look for the object cost within the object item. And so if I were just to highlight that and return that, we would see that that gives me the column that has the costs. And so now if I go to sum of that, it'll tell me the sum of the costs. Another way to do it, instead of with a $sign, is you could use brackets and a comma. And I'll explain what that means in just a minute. But just to show you that it returns the same results, I will return that. And you could also specify it by index number, by column. So what is happening here? So expenses, remember, we'll look at that again. Expenses is just a matrix that has 3 rows and 2 columns. And so one way that R remembers that is through brackets. And so we might say that it has 1 through 3 rows and 1 through 2 columns. And if I ask it to return me the first through the third row and the first through the second column, it's going to give me the entire matrix. So this is how you would index elements within a matrix or within a data frame in this example. So first you can specify which rows you want. So maybe you only want the first row. and then the first and second column, or maybe you want the first through second row and maybe just the third column. Oops, there is no third column. That's why it returns null. Maybe it's just the second column then. And so instead of doing it by number, you could also, like we do here, do it by name. But in this case, you got to put the quote. So instead of cost, we could do item if we wanted, and it'll list all the item names. So those are 3 ways that you can index within a data frame using the $, which will extract a named column. You could specify by the column name using an index like that, or you can specify a column name by number. You could also do this, all these things with rows except for that one. You can't reference the rows with a $. So let's go ahead and look at some other examples. So those were indexing columns. We could try to index rows. Let's say we want to look at how much the laptop costs. You would hope that you could do it that way, but you actually can't do that. Why didn't that work? Because if we were to look at expenses, right here is the name of the rows. And what this is telling you is your rows are named 1, 2, and 3. Laptop, books, and clothes it is a character vector of the variable called item. It is not the row name. And so that's not going to work. So instead, what I could do is expenses 1, and that'll give me the first row in the data set. Or you don't have to put it in quotes. You could just index by row number instead and say, give me the first row like I showed you earlier. But maybe what you really want to do is you want to say, give me the row that is laptop. I don't care what number it is. I just want the row that is laptop. And so in that situation, and maybe you don't even know, maybe this is a list of 100 items and you say, I know laptop is in there somewhere. I can't remember the row number. And so rather than hunting through it, you can use what we call a boolean or a logical statement. And so what we're going to do here is we're going to take the vector expenses $item, which contains these 3 things, and then we're going to do a double equals, which says, so a single equals says I'm creating an object. A double equal says is a question. So you're asking R, which of these is equal to laptop? And it will return a vector of what we call booleans, or true and false statements. And so that tells you that true, the first row is true, the second is false, the third is false, which makes sense. Laptop is the first item in the list, so everything else should be false. And so if we store that in an object, so just like we had before, we get true, false, false. Now what we can do is we can say expenses, open bracket, and then specify the rows that we want to keep. So before we did, 1 or whatever, or we could also go 1 and 3. But we could also go true, false, false. I'm just making explicit exactly what this is doing, and that's exactly what we are doing with this, is instead of writing that out, we are giving it a vector. And so that is saying, true, give me the first row, do not give me the second row, and do not give me the third row. And so that's how you would retrieve a specific index using a boolean. Lots of fun words here. Boolean. So now let's look at the third item. Let's go ahead and go expenses $item 3. And some of you might be inclined to do this. What's going to happen? It's not going to work. And here the error message says error in whatever incorrect number of dimensions. What does that mean? Well, remember what we have done here is we put a $. So we are saying to R, find the expenses data frame, and then within it look for the column called item. So now we went from a 2-dimensional matrix, which has rows and columns, to a 1-dimensional vector. And so it doesn't have rows and columns anymore. It just has rows, or just have columns, however you want to think of it. It's actually not either, but you can think of it that way if you want. And so it is now a 1-dimensional thing. And we are specifying to R, give me something that has 2 dimensions. That's what that comma means. You're telling R, this has 2 dimensions, and I want the first row in that 2-dimensional thing. Well, it's not a 2-dimensional thing. And so it's not going to work. Instead, to index the third item, there wouldn't be a comma anymore. And that just tells R that, yes, I recognize that this is just a vector. So now at this point, let's say we're doing our budgeting thing and we want to know which of these items is flexible. So we want to be able to invest in that iPad. So maybe we'll create an additional column called flexible. So we're going to do that by saying expenses $flexible equals, and then just a vector. And no problems there. By the way, that's how you can add an additional column. Now, let's say that you wanted to add something, but you accidentally put two things in there. It's going to bark at you. It's going to say replacement has 2 rows, data has 3 rows. So that's not going to work. But after we run that, oops, we misspelled yes. We put an extra S in there. I'm not going to show you the problem with that yet, but I will in the next step. Now, one special type of vector that R recognizes is called a factor. And so I'm going to show you an example of that. So we're going to recreate the column called flexible, except we're going to specify that it is a factor. So we've already got that in there, and now we're just basically replacing what we had before. But now we're creating a factor, and what a factor is it is a type of variable that you only permit certain types of values. So in this case, you specify the only things that this is allowed to take, which is yes and no. And again, assuming we didn't catch my intentional mistake, we would assume that would return basically the same as we had before. But let's go ahead and look at what we have now. We have yes, no, and then NA. And we might say, wait a minute! I said yes for the third one. What's going on here? What is going on here is you specified that this vector can only be yes or no. But you said earlier that there was a yes with 2 S's. And so now it's saying, hey, I don't recognize yes with 2 S's. I only recognize yes. And so it's going to say this value is missing because it doesn't fit within the parameters that you told me it must fit within. So let's go ahead and fix that last one. And to do that, we can reference it, or we can index it like that. And then we could say equals yes. And then now we've got our matrix that tells us what is flexible. And then maybe just to add some additional fun practice, what we might do is we might say which are flexible is equal to, and we're going to use a boolean like before. We're going to say expenses $flexible is double equal to yes. And just as before, that's going to return a boolean that says true, false, true. And now we can look at the expenses data frame where that condition is met, or where we only have the flexible data. And that'll tell us that laptop and clothes is flexible. So we could get a cheaper laptop, or we could spend less money on clothes, and then we could afford that brilliant iPad. Not a sponsored video, by the way, but if Apple wanted to sponsor me, then I've arrived as a YouTuber. So now what I want you to do is I want you to go ahead and practice. And I promise you, I have taught you everything you need to be able to do this practice. And the answers will be in the description. So what I want you to do is I want you to create the name, create a data set or a data frame that contains the following: the name of the 5 books you like, make that a character vector. The authors of these 5 books, also make that a character vector. And then the genre of these 5 books, and make sure that is a factor. Wow, I said that kind of funny. Make sure that is a factor. And then number 4, go to Amazon or Barnes & Noble or Goodreads, whatever you wanted to use. And then report the star rating. And then also create another column that has the cost of the book. So you're going to have 5 columns in total. Then what I want you to do is to compute the average star rating and cost of your favorite books. Then I want you to index the 3rd book's rating. And then here would be a tricky one. I want you to sum the price of those that are for one specific genre. So maybe you have science fiction and mysteries. So maybe you choose mysteries, and then you compute the sum of those that are for that one genre. This last one's going to be a little bit tricky, but I have taught you everything you need to know to do it. Again, in the description, I will show you my code and my favorite books, and that will help you. But I would encourage you, before you look at that, to try it on your own, and then look below to see if you have made any mistakes. Hopefully you haven't. So with that, let's review our learning objectives. So again, know what objects are. Those are things that R stores in its memory. Know what a character vector is. So that is a list of things that have been put together that are all characters, or all words, basically. Also, know what a numeric vector is. So like a character vector, it's a bunch of things stringed together, but they are all numbers instead of characters. Also know what data frames are. So data frames are like Excel spreadsheets. They have rows and columns, and it's a way to store information. Also understand what the final paper idea is. Again, the idea is that we want our R script to be self-contained, that we could just run it from the beginning, that we could just restart R, run things from the beginning, and there are no more mistakes, and we clear all of our mistakes, and we have just what we need to run our analysis. Also know the 3 ways that we have indexed data frames. One is by using the $, which selects a specific row. One is by using commas and quotes, which is also for selecting specific columns usually. We can select specific rows, but usually we select columns. And also by index number. Also know how to index specific rows, so we could do that with the name of the row, which is kind of unusual, or we could use that by index number. Also know what booleans are. So again, booleans are true or false statements, and we could use those to identify rows, or you could do it with columns too, that meet specific conditions. Also know how to use that in R. Also know what factors are. And once again, factors are basically like character vectors, except you specify that they must be specific values. And one thing I didn't mention before is like, what's the big deal? Why do you have to specify that they fit into specific values? Well, I guess you can say part of it is kind of a quality control issue, that you want to make sure that you don't screw something up and put in something like I did here with a yes with the 2 S's. But there's a lot of people in the R community who think factors are kind of a terrible idea. I don't really care, but I do know that there are certain types of analyses in R, random forests for example, that require your characters to be converted into factors first. So I wish it weren't necessary for me to make a distinction, but for some analyses it is. Luckily for you, if you're using FlexPlot, that doesn't matter. FlexPlot in the background automatically converts things to factors anyway. So, yeah, I think that covers the basics of R. That was probably a lot of information, you poor soul, but I would recommend doing the practice exercises, reviewing the learning objectives, and if you have any questions, drop them in the comments. Thank you very much. We'll see you next time. Peace out.